So today we are talking about functions, what they are and how we talk about them and how we write about them using symbols. And a function is basically just a rule. It's a rule that allows us to predict the output if we know the input. So we've been practicing with some rules, and this is a picture kind of a function machine. And we've talked about the fact that what number you put in, you follow the rule, and then the output is a function of whatever input you put in. What happens as the output depends on the input. So that's what a function is. We did some work with functions that showed growing with tiles or blocks, and you'll notice that this particular function, the figure number, is your input, right here, your fig number, and the number of tiles is your output. So we would say that n is the figure number, and the y, or the f of n, is the number of tiles. It's kind of important to know what you're talking about when you are dealing with functions. In this case, we can see it, and the table shows us that the way this one's growing, I should give you time, or you should pause it and you could spend some time with it, but this one's growing by the figure number times the figure number plus 1, so 1 by 2. The figure number of 2 by the figure number plus 1, 2 times 3, 3 times 4, 4 times 5, etc. We could easily talk about the 50th as being 50 times 51, but here's our rule right here. Depending on what your n is, your output is going to be n times n plus 1. When n is 5, it's 5 times 6. When n is 6, it's 6 times 7, n plus 1, etc., etc. So a rule, a function, is just a way of predicting the output. When we talk about functions, rules that allow you to predict an output if you know the input, there's symbols that you need to understand. So most of the time we will see an input as being an x, and the output is the value that we call y. But also the input can be x, and the value that is the output is f of x. And that just means that the output, the whole thing, depends on what x you have put into the rule. So this is called f of x, but it just means that the output depends, or is a function of x. Because of that, these are variables. The letters are called variables because they change, vary. We often talk about the x being the independent variable. And because the output depends on the input, then the y is called the dependent variable. With the tile patterns that we talked about in the previous slide, you'll notice that the input was n because we were talking about a figure number, and then the output was f of n, or t of n, the total for this figure number. So don't get confused by it. All of these here are synonyms for the output, and all of this in the first column are synonyms for the input. So here I'm going to show you a special kind of function called a quadratic function, just so we can understand, that's not quite what I wanted to do, understand how the table connects to the graph, connects to the rule. So here's a quadratic function. Quadratic functions always have some sort of x squared in them, and this particular one is x squared minus 1. And that's the rule, and here is how we would write with function notation the output. So that means that the output depends on what we put in for x squared. So I'm going to go ahead and show you a couple of inputs and their output and how that relates to the graph. So I'm going to go ahead and let x equal -2. and I'm going to put -2 into, I left some workspace here to show the work on paper. Some people can do it in their head, some people need to keep it written down, and that's just fine and dandy. -2 squared is positive 4, 4 minus 1 is 3. So then we have a point, -2, 3. This point right there is one of the input-output pairs or coordinate pairs for this. Now I'm going to go ahead and erase this. No, I didn't want it that. I want to erase it. Erase this path, because we don't need that path when we graph our points. We just need the point. So then we're going to go ahead and do a couple more inputs and outputs. I'm going to go ahead and do an input of 0. Always a good idea, and pretty quickly you'll notice that when we put an input of 0, whatever the number is that's left, like 0 squared minus 1, it's going to be 0, -1. And sure enough, here's 0, -1 right there on our graph. And then I'll do just an input of 1. So we can see that one. 1 squared minus 1. 1 squared is 1. 1 minus 1 is 0. And sure enough, here it is right there. So that the rule right here can be translated into a table of values. And then every point on this graph follows this rule. So if I put in 2 squared minus 1 is 3, sure enough, there it is. Every point on there fits. Okay, the last thing I want to talk about is what if you see it where a number has been written right here. What does that mean? What it is asking for, what is the output when x is 16? So let's say the function was the square root of x. Okay, so then we'd be talking about what is the output when x is 16, it'd be 4. Or if f of 16, if the function was x minus 2, then it would be 16 minus 2 would be 14. So it just says place x in, find the output. And so place 16 in, find the output. That's all it means.